All right, number 1 says to find the area and the perimeter. So to find, should we find the perimeter first? Yeah, we should. So we have the distance around, we have everything except this corner right here. How can we find the width of this right here? 20 minus 14, so that's gonna give us 6, right? What about the vertical small piece? 11 minus 6, which is 5. So when I add the distance all around, we have 2 6s. I'm gonna go ahead and kind of add partially as I go. 5 and 14 gives me 19. 11 and 20 gives us what? 31. And then we know that's gonna give us 50, correct? I see 62, do you? Okay, 62 feet, that's our perimeter. To find the area, there are 2 methods to go about this. You can separate this into 2 small pieces and add it, or look at the big rectangle overall and subtract the tiny one, okay? But I wanna stick with this one right here. So I know I have 14 by 11. How many is 14 by 11? 154. Do we agree on that? So 154. And what about 6 by 6? 36. And when I put 154 and 36 together as how many? 200? 190? So we have 190 feet squared. So this one really did not need a formula. It's more like, can I separate it? Or can I look at the big minus the small? Whichever method you want, does not matter. We'll get the same thing. Number 2 sounds familiar? Okay? We won't say any more because, all right. To find the area for this one, and actually I want to start with the perimeter just because, why not? If I know this is 15 over here, what do I know about the opposite side? Also 15. And we have 2 semicircles. Together will create what? A whole circle. So we know circumference is 2 pi r. Then that's going to give us, someone get him. Put them away. All of them away. So we have 2 pi times 4, and that's going to give us 8 pi. What was the question?
Isn't there also a formula for circumference that's just like pi d?
Yeah, pi d works.
Okay.
I like the radius because the radius is going to be the same for pi r squared for the area, but it's fine. Okay. So we have, for this one, that's going to give us the total perimeter of this figure. The 2 15ths will give us 30 plus 8 pi. And when you're ideally putting 2 components together, where are we? Plus who?
Plus or minus.
It's plus because those are the side lengths for those 2.
Mm-hmm. So we have centimeters. You don't really need the parentheses, but it's to say all of those 2 components are both the same units. Now let's look at the area. We're looking at the area of this figure. So for this figure, looks like I need to look at the whole thing as a rectangle. So if I take the rectangle minus the area of the circle, would that give me that? For the rectangle, it's 15 times 8. How many is 15 times 8? 1 how many? 120. And then if I do pi r squared, and we know we have pi 4 squared, how many is that one? 16 pi. Does 120 also have a pi? No. So just put it at the beginning. Do not combine them. And that's going to be the area of this figure. And I'm going to wrap that up with the parentheses to say we have a common unit. Boom. Okay, number 3 and number 4 has to do with our special rate. Y'all remember the ratio of 45, 45, 90? 30, 60, 90? We're doing quite a bit of it. So for number 3, it says to find the area of the shaded region. So it looks like I need to take the area of the circle and subtract out what? Square. So I'm going to kind of visually make this. Area of the circle minus area of the square. Which one can I find at the moment?
Square.
The circle, the square, which is how many? 36. Now for the circle, I need to find the radius. Let's call this r. And it looks like I can go ahead and make another one, make it perpendicular. So let's make our ratio. We have r over 6 is equal to, now isn't this 45, 45, 90? Because in one circle, the radius is always the same. So we know r is opposite of 45. What number do you remember that's opposite of 45? 1. How about opposite of 90 degrees? Radical 2. So we have r radical 2 is equal to 6. And I'm going to do something where you're going to go, well, why are you doing this? Normally, I would rationalize, right? But let's kind of think ahead. If I were to write out area of a circle is pi r squared, and we analyze when I square the radius, what is going to happen to my, it's going to cancel out. It's going to cancel the radical. So if you can rationalize it if you want, but if you notice that we're going to square it, you don't need to because you're doing too much work. We'll get the same answer though. So on here we have pi 6 over radical 2 all squared. And that's going to give us pi 6 squared is 36. Square of the radical 2, what pops out? 2 pops out. So really in the end, that's going to give us 18 pi. Now, do they both have a common term of the pi? You leave that just fancy, and we're going to write out 18 pi minus 36, and we're looking at centimeters squared. So again, if you wanted to rationalize, you may. All right, let's look at number 4. And I want you to go ahead and work with the partner on this, and I'll go ahead and tell you where you can find the radius. Go. Let me give you about 90 seconds to start, or maybe you could finish.
Couldn't you find the apple or no?
I wouldn't. There's an easier way. Just find the radius by 30, 60, 90.
It's 30, 60. Come on. It's huge. That's one of my biggest sweatshirt, and I love it because I
This is 36. And you do it like that. That's a 30. This one's a 36. So it's not going from there to this. That point there.
That's there. Boom.
Good method. Use what you got.
Teachers and staff, please pardon this interruption. We have 2 sets of students testing today. An email went out. Look for an email from Emily Dragu and from Ashton Tilley. We have both telecast listening and speaking happening. And we also have makeup ACT and extended time ACT. If you will please look at those lists and send kids to where they're supposed to go right now, we would greatly appreciate it. The second thing I want to let you know about is that there will be no bells due to this testing today, so please do not release students early from class. Thank you.
All right, to find the radius, did you use 30, 60, 90? Okay, we knew it was 30, 60, 90 because in an equilateral triangle, all the angles are how many? Congruent, meaning they're all 60 degrees. So if I cut this one in half, that's going to give us 30 degrees. So let me go ahead and zoom this one in so we can see it. So that angle is 30. Here's my right angle. So we know this one has to be 60. Here's my radius. And I know given that one side of the triangle is 6, what do I know about this right here? 3, So let's write out the ratio. R over 3. R is opposite of the 90 degrees. What was the ratio for the opposite of 90? 2. How about the 3? Radical 2. So we have R radical 2 is equal to 6.
I thought it's radical.
Is it radical 3? Yes. Oh my goodness. 2 should not repeat. Thank you. Whoever caught it, you're awesome. So we have R is equal to 6 over root 3. What's up?
Why is 60 the top angle?
Why is 60 the top angle?
Yeah.
Think about central angle is 360. There's 3 sides in an equilateral triangle, meaning there's 3 central angles. So each of them is
60, right?
120 divided by 2, 60. Just like when we were looking for the apothem yesterday. All right, do I want to rationalize this? No, you're doing too much work. So if I have pi r squared, we're looking at pi 6 root 3 all squared. That's going to give us pi. That was the same thing as the one above. Why am I even doing all that work? Actually, no, not really. Because we have radical 3. Oh, goodness. 36, 3. So is that 12 pi? 12 pi. And these do not have like terms. So do I need to combine them? No. Just leave it fancy like this. And it's okay. And that's going to be, are they all in centimeters today? Voila. Okay, what 2 shapes do we see that we need to incorporate on number 5? Trapezoid minus the right triangle. Let's draw that image. We have our trapezoid minus, what's up? You can. Yeah, we can do that. Let's go ahead and find the height of the first right triangle. So let me highlight that piece. Is this clean? This number does not look clean.
What do you mean? Oh.
It's not a pretty number. I was hoping it to be like a, what is it? Pythagorean triple, but it's not, right? Was it one of the triples? 8 how many? There was one that we did that I did not count for. So I'm going to go ahead and try this. Hold up. Whoa, what was it, Alexa? Yep, it's 15. It was the 4th Pythagorean triple that I typically do not remember. But we can use Pythagorean theorem. A squared, b squared, c squared. Okay? All right. Let's go ahead and find the area of the trapezoid. The area of the trapezoid, let's do a recall. It was a height times base 1 plus base 2 divided by 2. Our bases are the ones that's connecting from the height. So the height is perpendicular. So we have 15 times 16 plus, what's the other base? 28 divided by 2. Is that pretty messy? Let's try it without a calculator. What is 16 plus 28? 44? Ugh. Not very pretty.
Wait, why is 44 divided by 2 is 22?
But 22 times 15 is not pretty.
Could we do like 7.5 times 22?
No, I'm going to type it in. You guys never saw this, okay? So we have 330. I know you're impressed. It came from my brain. I did it. I went. All right. Now we have to go in and subtract out the piece that's not shaded, which is a right triangle. So we know that one is going to be, isn't that base times height divided by 2? So we know our base and height are perpendicular to each other. So my base here is 20. The height is 15 divided by 2. Oh, that's doable. 10 times 15 is how many? 150. So if I take 150 out of that, we're going to get how many?
180.
Is that right, 180? Okay, so we got 180 centimeters squared. Voila.
Boom.